Hello, and welcome back to my Kubernetes series. In this video, we will deploy a replicated database. Video 5 and 6, in which we deployed dynamic storage provisioners, prepared us for this step. Without further ado, let's take a look at the database we will be deploying. The application I chose is the Mariadb Galera cluster implementation from Bitnami. There were three main reasons why I chose this application. Number one, the database replicates all changes automatically to all other pods in the cluster. Number two, you can easily scale the application to your needs. Let's say you have 7 or more worker nodes, you could run 5 replicas instead of 3. Really nice. Number three, it is an all-in-one solution for the database and the replication. I do not have to deploy 2 applications or develop something complicated myself. That was already done for me by Bitnami. As I identified the application I will be using, let's look at the option to install it. Obviously, my favorite way of installing apps in my cluster is Helm. If we scroll down on the website and find the entry for Helm, one thing that jumps out is the chart address. And you might ask, but we haven't even added a repo to Helm. What's going on here? The way how the installation process is described here on the website is another way of providing a chart. Instead of adding a repo, the OCI address is provided instead. OCI stands for Open Container Initiative. Well, at least that's one definition I found. Anyways, you provide this address and then you use Helm as normal. You enter a command helm show values and provide the OCI address and you get the values file. Same for the README and other details. To be honest, not my preferred way. I do prefer to add a repo and search that repo on my own system without having to navigate websites or GitHubs. Personal preference. So please decide for yourself what option works best for you. I had to search a bit to find the address for the charts, but with a bit of help from a search engine I was able to find the repo for Helm. I will put that on the screen and leave the command in the video description. The reference was removed by Bitnami from their website and as you can see from GitHub as well. I will go ahead and add that repo to Helm. So let's get this journey started and switch over to our terminal. To add the repo, we enter helm repo add Bitnami https://charts.bitnami.com/bitnami. As the repo is added, as usual, we enter helm repo update. And our repos have successfully been updated. Now we can search for our chart with helm search repo Bitnami, and you will see quite some charts. We can scroll through. Mariadb Galera, there it is, perfect. So we have the chart in here, but as you can see, Bitnami offers a wide variety of charts aside from the database. But I am only interested in the Mariadb Galera cluster, so we will go into our setup folder. We'll take a look and mkdir 08 database. Enter the folder and download Bitnami's value file for the Mariadb Galera cluster with helm show values Bitnami Mariadb Galera, and we output that into the values file values.yaml. Let's take a look. We have the values file and can now start customizing the deployment. Before we do that, however, I also want to show how to work with the OCI address. It's fairly similar to working with a repo. All you have to do is helm show values, and then you enter the OCI address registry-1 docker.io /bitnami charts /Mariadb Galera. As you can see, you get the output, the values file. We can also helm, I probably should have copied that address, helm show readme OCI registry-1.docker.io /bitnami charts Mariadb Galera. And we get the values file, not the values but the readme file, which is fairly long, as you can see. We have all the values that you can modify, and right here is the first line. We're working with a chart version 10.03, which is important in this case. Helm search repo Bitnami /Mariadb Galera, and we should find only one line, out of which we can take the chart version 10.0.3, which was the same as from the OCI address. As we verified that the chart versions are the same through the OCI address as well as the repository we added to Helm, let's now empty our screen and start customizing the values file to our needs. We'll start right at the top of the file. We won't change anything up on the top. The full name will be provided through the console. Diagnostic mode is not on. I'm okay with that. We are working with the app version 11.1.2. That's fine. Debug mode is false. Ordered ready. That's fine. Services, cluster IP. That's fine. Cluster IP ports. We're going to stick with the standard port. Node port. Do I need a node port? Specify the node port value for the load balancer and node port service types. I don't believe so, not at this moment. Node port MySQL. Load balancer IP, we'll leave that as is. External traffic policy is cluster. Session affinity. Let's move further. Service account. By default, the service account is deactivated. We're going to change that and say we want a service account to be created. And in here, we're going to specify it as Mariadb Galera Manager. Going to continue. RBAC, absolutely. We want that set up. Pod security context, so we're not running as a root, which is great. Container security context as well. That's fantastic. Now, root user, how do you want your root user to be called? Going to change that. obviously going to hide the password. We do not have an existing secret. Use password files false. Database. Database user. I will not create one. No password. We're going to create a standard database. My database, that's fine. We're going to delete that anyways later on. That's just for the startup. The Galera bootstrap. Alright, Maria backup. So there is a user created for the backups. It's called Maria backup, and I will leave that user, but I will input another password for that user. Force password is false. I do not have LDAP, so I'm going to ignore it. However, TLS, I will enable TLS. It's true. Auto-generate the certificates. True. I would have loved to use my own certificates. However, the creation of the CA cert file or cert CA file name would have been too much of a hassle. So I just let Mariadb create its own certificates, which will then be used for the internal communication to encrypt the traffic through TLS. I will not touch the Mariadb config. I'm going to just scroll past it. Configuration map is fine. Replica count, I want 3 replicas. For my cluster, that is sufficient. But as I mentioned earlier, if you have 7 or more worker nodes, you can easily scale up to 5 or even more. Rolling update is fine. Node affinities, I don't want node affinities. Container ports, they stay as they are. Persistence is true. And now in here we want to specify the iscsi storage that we configured and implemented in our cluster. Alright, let's go back up to the top because we need to change a few things. So enable true, of course that stays, but we have no existing claims. So we will ignore this setting. Subpath we won't change. Mount path in the container, that is where the external storage mount is mounted. That's fine. I'm not going to touch that. Selector, but storage class is what we want to update. The storage class, if you might recall, was iscsi storage. With that value, the database will call on the storage class and request the provision of a storage. And our provisioner should automatically provision this storage to make it accessible for our database. Next is the access mode, read write once, that's okay. 8 gigabytes in size is what we request. If you remember back, we have a total space of 10 gigs in that image file, which we used as backing storage for the iscsi. And priority class, init containers. We want to continue through the files. Sidecars, we don't have any. Extra volumes, we don't have any. Resources, we will not limit. And we're down to the liveness probes. I had in my tests a few challenges with the liveness probe, so I'm going to change the time in here, and I'm going to double the delay seconds. It's going to take us quite some time to start the database cluster up, but I want that to be successful in order to avoid any rework. So we're going to change the periods in second and the timeout. Successful threshold 1 and 3 will keep. Next one is the readiness probe. We will also change that to a multiplier of 30, and we're going to change the periods in second as well, and the timeouts. All right, let's go further down, start up probe. We're going to take a look at the startup probe as well, but we're going to keep that except for the timeout seconds. We want to increase that, and the rest will keep the same. Pod disruption budget, won't change it. Metrics, I'm not going to change any of those values here. Service monitor, that's fine. Not going to change that either. Prometheus rules. And we're at the end of the file. We're going to write and quit. And before we deploy the database cluster, I'm going to split my screen. Once I've done that, I'll be back so we can watch our deployment. As I split my screens, before we deploy the database, we're going to create a namespace. I want to deploy my Mariadb Galera cluster into a namespace called database. So we say kubectl create namespace database, kubectl get namespaces, and there is our namespace. On the right hand side, we can now start our watch with watch kubectl get all-n database. And of course, the namespace is still empty, so we won't see anything. On the left hand side, we want to deploy the database with helm install Mariadb Galera cluster Bitnami Mariadb Galera, the values file, into the namespace database. All right, I'm very excited. Let's do it. While we wait for the last pod to successfully start up, as you get the deployment successful output message from Helm on the left hand side of your screen, we'll save this command or the output in a file on my machine. I will copy and paste this item, including the version. And we'll go through some of those commands. As I mentioned in a previous video, those commands are invaluable as it could be hard to get this message displayed again. But especially in this case for the database, you get certain commands that you absolutely need to have. For example, if you want to access your database, you have to run the command that is currently highlighted on your screen. All of it. That creates a pod within the namespace database, and this pod allows you access to the database and to manage and enter data into that database. I will especially copy this piece in a file on my system, and if you want to do so, you can even create an alias that will allow you to just call this alias and then access the database. I know there's also a way to display this output again without having to uninstall and reinstall the database. I found that once, but did not write it down and could not find this command to execute again. As our database is fully deployed and completely ready, as you can see around the stateful set, which says 3 out of 3 ready, we can now see if we can actually access the database. As I've highlighted previously, the command we have to execute is the one right here highlighted on your screen. So we're going to paste it and we're going to execute it, and as you can see on the right hand side, a client pod is starting up, which will allow us access to that database. Once this pod is started up, on the left hand side we should see the console should change, and it should show us that we are accessing the database. So we'll let this startup finish. Alright, the pod terminated because of a timeout challenge. Okay. Pod already exists. Gotta wait until it's deleted again. And let's try this once more. And as you can see, we now are within our database. We can verify that with show databases. And we can see there are a few databases in here. The default information scheme, then the database that was created through our Helm chart, MySQL standard performance scheme, sys, and test. Use test, show tables. There are no tables in here, so we can go back to my database, show tables, and that is empty as well. Nevertheless, we managed to access our database, and we're going to exit. Once we exit, the pod that was started up is showing complete and is being removed from our namespace. Before we recap this video, however, I want to talk a little bit about the troubleshooting I had to do while deploying this chart. As I was deploying the database, I ran into some issues that the database got stuck in a pending status. As it turns out, some of my iscsi backed storage turned from a read-write mode into a read mode only. My strong suspicion was that during a backup the files were locked, and that's why they were then turned into a read-only on the nodes. So I have to take care of not making sure that this backup does not copy those files anymore and saves them, as I will extract the data out of those image files anyways. That's not going to be a big deal. However, at the moment, what I have to do is I have to reset those nodes, make sure that the storages will be attached as read-write, and then I should be able to run my databases. Even though the first pod, or the first part of the database, seems to be now running, which is running on a node which I already verified that I have read-write access, I will nevertheless uninstall the database and then reinstall it once all my nodes have write access to their iscsi storages again. One more item I would like to point out is noted in the README file. So let's bring that README file up with helm show README Bitnami Mariadb Galera. In this README file, I want to scroll up a bit to the section where Bitnami talks about the bootstrapping process, which is right around here. The bootstrapping, once a bootstrapping is done, a file called grastate.dat is created, and it contains a value called save to bootstrap. And at least for one node, this bootstrap should be 1. However, if a cluster is not a database cluster, not the Kubernetes cluster, database cluster is not shut down properly, the save to bootstrap might be set to 0 for all of the nodes that you have running. The explanation in here gives us a good indication what to do next. In this case, the cluster was not stopped cleanly, and you need to pick one to force the bootstrap from. So you pick a source. The one to be chosen in the one with the highest sequence in Bitnami grastate.dat. So whatever cluster you use, or whatever node you use the highest. In my case, that would be Mariadb Galera cluster 2. That's the pod. And then the following example shows how to force the bootstrap from the last node to the first one. So once that's done, once you follow this command here, force bootstrap true, bootstrap from node 3, force save to bootstrap true, and the pod policy parallel. Once you execute this full command here, everything which starts with helm, then your cluster will be restored and the data will still be available. Sweet, that's it for this video. As I said, such an exciting implementation, and if you still ask yourself why this guy is so obsessed about a simple database, this database is the foundation for everything that we will do going forward. Nextcloud, Postfix, Dovecot, Zpush. We will be able to use it across our cluster and deploy different items, and the database replicates itself to avoid data loss. That is why I'm so excited about a stateful set. So let's recap. What is working? With this video, by deploying a database cluster, we laid the foundation for any other videos that will follow. What is left to do? The remaining items we want to deploy are Nextcloud and an email server with Dovecot and Postfix. Of course, we don't want to forget a synchronization with active sync capable devices such as Android and Apple phones, as well as email clients that support said protocol. The implementation we'll be using is called Zpush. What's next? In the next video, I will be going through the implementation of Nextcloud in a microservice structure. I will walk through an article I found from Marco Skender, and how I used his fantastic work and upgraded to some of the latest deployments of the software he mentions in his article. That's it for this video. Thank you so much for watching. I will see you in the next video.